a column of vapor appears above a world that should not be venting anything at all. Far above Jupiter, this frozen moon turns in silence beneath a shell of cracked ice. From a distance, it looks closed, stable, locked away from space. And then, in observations from the Hubble Space Telescope, enormous columns seem to rise above the surface, reaching hundreds of kilometers into the darkness. The image creates a problem before it creates an explanation. If those observations are real, something inside Europa is finding a path outward. Not a wide opening, not a visible hole, just material appearing where no easy escape route should exist. Scientists call them water vapor plumes. The important part is not what they are. It is where they may be coming from. Europa is believed to hide a vast ocean beneath its frozen exterior. If vapor is truly being pushed above the surface, the ocean may not be completely sealed away from space after all. Yet the moment that possibility appears, certainty begins to disappear. The plume is visible, its contents are not. Observers can watch something rise above the ice. They cannot look directly into the source. They cannot say exactly what is being carried upward. The evidence arrives first. Access does not. And that is why a frozen moon suddenly starts attracting so much attention. Something may already be escaping from a place humans cannot reach. Colored regions begin appearing across Europa's surface, like evidence markers at a crime scene. As instruments scan the ice, certain areas stand out. Long cracks, broken ridges, streaks crossing the frozen shell. Chemical signatures appear in those regions, and they do not appear only once. Similar patterns show up again and again, as though material has been transported upward and left behind. The Galileo mission helped reveal some of the most important clues. Carbon-bearing materials appear on the surface. Ocean-related salts appear there as well. Each new signature creates the same problem. Scientists can measure the trace. They cannot verify the source. The more evidence appears above the ice, the more attention shifts toward something hidden below it. That sounds useful. It also creates a dependency. Every major conclusion now depends on the place nobody can directly inspect. The chemical fingerprints keep accumulating. Direct access never arrives. Europa may contain more water than all of Earth's oceans combined. That is not the reason scientists keep returning to it. The reason is what keeps appearing on the surface. Salts associated with ocean chemistry, carbon-bearing compounds, repeated chemical signatures concentrated around fractured regions of the ice. Individually, none of these observations prove an ocean. Together, they keep pointing in the same direction. And every new dataset makes that direction harder to ignore. For a moment, the picture begins to look unusually coherent. The ocean explains the plumes. The ocean explains the salts. The ocean explains why the same chemical signatures keep appearing near fractured regions of the ice. Measurements collected years apart start pointing toward the same possibility. Not certainty, but a model that requires fewer and fewer adjustments to remain intact. There appears to be liquid water beneath the ice. Chemical ingredients associated with habitability appear plausible. Sources of energy appear plausible too. For scientists searching for potentially habitable environments, those three conditions appearing in the same place is difficult to dismiss. Over decades of observation, these separate clues begin fitting into a single picture. The surface, the ice shell, and the hidden ocean no longer feel like disconnected mysteries. They start behaving like parts of the same system. This is the stage where uncertainty becomes quieter. A working theory forms almost naturally. Material moves upward from below. Surface measurements reflect conditions deeper down. The hidden ocean becomes the central explanation that allows the evidence to fit together without constant adjustment. Even future mission planning, including the Europa Clipper effort, grows from that increasingly coherent view. The goal is not to invent a new possibility. It is to investigate one that already appears consistent with what has been observed. For a moment, the tension eases. The frozen moon no longer looks like a collection of strange measurements. It looks like a place, a possible environment. And that comfort creates its own risk. When enough clues align, possibility can begin to feel like confirmation. The model becomes familiar. The story feels complete, yet the ocean itself remains out of sight, hidden beneath the same ice that started this investigation. The pieces fit together, perhaps a little too easily. For the first time, Europa starts looking less like a mystery and more like a solved problem.
Sustained monitoring of the ice shelf reveals active venting.
The ocean explains the plumes. The ocean explains the chemistry. The ocean explains why the same signatures keep returning. A hidden ocean becomes the answer that seems capable of carrying almost every unexplained detail at once. And that is exactly why confidence starts growing. Two observations now exist side by side, and they do not fit comfortably together. Material may rise from below the ice and reach Europa's surface. That idea supports many of the conclusions built so far. The problem begins after the material arrives. Europa does not move through empty space. It turns inside Jupiter's magnetosphere, one of the most extreme radiation environments in the solar system. Anything exposed on the surface begins changing almost immediately. Molecules break apart. Chemical structures are altered. The longer material remains exposed, the less it resembles the place it came from. Scientists are not reading a preserved sample. They are reading what survived. Material reaches the surface. Time passes. Radiation reshapes it. Only afterward do instruments measure it. The evidence still exists. The path back to its source becomes less direct. That changes the meaning of every measurement that follows. Researchers are not comparing observations to an untouched sample from the hidden ocean. They are examining material that may already have been rewritten by its environment before any instrument ever arrives. The contradiction is difficult to ignore. The same measurements that keep Europa interesting are also the measurements most vulnerable to distortion. The clues remain visible. Confidence does not grow at the same rate. And an uncomfortable possibility begins to appear. We may have been studying Europa's ocean for years without ever actually seeing it. A vast ocean may be sitting beneath Europa's ice right now. The data continues to arrive. The picture becomes clearer. The source does not. That tension now defines almost everything scientists think they know about Europa. Yet every piece of information passes through the same long path before reaching human eyes. First, there is the hidden ocean. Then, layers of ice. Then transport toward the surface. Then, exposure to space. Then, measurement. Then, interpretation. Every step removes something. A little context. A little certainty. A little direct access. By the time knowledge reaches Earth, it has already passed through layers of ice, radiation, distance, and interpretation. That does not make the evidence worthless. It changes what kind of evidence it is. Europa remains buried beneath kilometers of ice, hundreds of millions of kilometers from Earth. The ocean influences the surface. The surface influences the measurements. The measurements influence the conclusions. Yet the ocean itself never fully enters view. This is why missions such as Europa Clipper matter so much. Not because they promise direct access, but because every new observation may help reduce uncertainty around a place that still refuses to reveal itself completely. And that may be the real discovery. Some environments reveal enough evidence to transform human priorities while remaining physically inaccessible to certainty. The closer humanity moves toward understanding Europa, the more clearly another boundary comes into focus. Not a boundary in the ice, not a boundary in space, a boundary in knowledge itself. The vapor reached space. The measurements reached Earth. The ocean never did.